Hello and welcome to this Edexcel Chemistry GCSE course. This is lesson 1 and we're going to be taking a look at the states of matter. Before we get started though, I just want to take this opportunity to recap some of the knowledge you might have from primary school or Key Stage 3. So I've got 3 questions here for you to have a go at answering. Grab yourself a piece of paper, it can be scrap paper, that's not a problem, and have a go at answering these questions. What is the difference between ice, water and steam? How are they similar and how would you draw them? You can pause the video now, take some time, have a go at answering these questions, and when you're ready, you can hit play again. So I've just asked you to have a go at answering these 3 questions. Now, most people would be able to identify that ice, water and steam are all made of the same substance, which is water. You might use the word chemical. Now, we don't normally think of water as a chemical because we drink in it, we wash in it, you might swim in it, but it is a chemical. It doesn't do us any harm. A lot of times when people hear the word chemical, they think of something that might do us harm, like they might think of bleach or they might think petrol's a chemical. So all 3 of those are made of the same substance, which is water, but the differences between them are that ice is solid and water is a liquid and steam is a gas. So they're in different what we call states of matter. Now you might have drawn them, you might have drawn sort of an ice cube and then maybe a puddle of water or water in a glass and then maybe steam coming off a saucepan or a kettle. But what we need to be able to do is draw them scientifically, draw them the way they need to be represented for your GCSE chemistry exams. So what we're going to do in this lesson is we're going to take a look at the states of matter. Now this is covered in Key Stage 3, so you might have seen some of this content before. The ideas and concepts haven't really changed, but what we must do is make sure that we can talk about these states of matter using the correct terminology, the correct keywords, because that's what's going to get us the marks in the exam. So what we need to be able to do today is we need to be able to describe solids, liquids and gases, and specifically the arrangement and the movement and the relative energy of these 3 states of matter. So we're going to look at the particles, how they're arranged, how they move, and the relative energy, so how they compare to each other in terms of energy. We need to be able to recall names that are used between the 3 states of matter. Okay, so this could be how one changes to another. So you might have heard of things like evaporating or condensing. We need to use these and use these correctly. What we also need to be able to do is recognize that these are called physical changes instead of being chemical changes. We need to explain changes in arrangement, in movement and in energy. So not just talk about their actual arrangement, but changes in arrangement as well, and be able to predict the physical state of a substance under specific conditions. So for example, a very simple one would be, if I put water into a freezer and leaves it for 24 hours, what would its state of matter be? Most people will be able to tell me it would be a solid, it would be ice. What we need to be able to do is do exactly the same thing, but for some slightly harder examples. So, the states of matter. Let's make sure we understand what the word matter means first. So matter is anything that has a mass and anything that takes up space. So, for example, you're made of matter. You are made up of lots and lots of different types of chemicals. You've got protein, you've got carbohydrates, you're made of water. and you have a mass, you take up space, and therefore you are made of matter. A pen is made of matter, the table is made of matter. There are three types: a solid, a liquid, and a gas. So this one here is our solid, this one in the middle is our liquid, and then at the end here we have got our gas. Now for your GCSE exams, you need to be able to identify these, and you need to be able to draw them as well. So before we get on to describing them in more detail, we need to make sure that we can recognize them. So whenever we see a particle diagram, and that's what these three pictures are, they are particle diagrams, diagrams of how the particles are arranged in a solid, a liquid, or a gas. But in a solid, we always get these rows, and we have this uniformed shape. So we've got them in rows and columns all lined up, and all the particles, that's what these circles are, they're individual particles, are connected to each other, they're bonded together. So that's why we've got them touching. Liquids, on the other hand, they are all touching. So to make this one complete, we should have another particle in here to make those ones touching. And now every particle should be touching at least one other particle. But they are able to flow or move over each other. And they have an irregular structure. They're still quite compact, but they're not quite as dense as a solid. Then we've got a gas. And our gases, you can see these particles are not touching, and they are spread out as well. So that's what our solids, our liquids, and our gases look like. So now we know what they look like in terms of the particle model, we need to be able to describe them in a little bit more detail. Before I move on though, it's important to mention that a substance can usually exist in all three states of matter. So water could be ice, like the beginning picture, melt into liquids, and then evaporate into a gas. But it could also condense as well back into a liquid and then freeze to become a solid again. And most other substances can do the same. Not all of them, some of them might not. That just depends on the conditions we can create on the planet. But normally, if you change the temperature, you can change between them, and also the pressure as well. But we'll get onto that a little more later on. So let's start off with solids then. Solids are one of the three primary states of matter. So as we've seen the particle arrangement. Now we need to describe it. You saw that they are arranged in a highly organized structure. Sorry, that should be, I haven't spelled that right, that should be an S. Put the American spelling in there. And often in a repeating pattern, which is what you saw in the previous slide. You saw those circles in rows and columns, nice and organized. They also have some distinctive characteristics. And these are the key words that we have to use when we describe a solid. We need to say that they have a fixed shape. So solids have a defined or definite shape, and they maintain their form regardless of the container they're in. So if you take a coin and you put it in your money box, it's still going to stay the shape of the coin. It's not going to change. Okay. They also have a fixed volume. Okay. Which means that because the particles are closely packed together, which we saw in the picture, they were already close together and touching, they do not compress easily. So we can't compress them, we can't squash them, and so they have a fixed volume. So these are the two things you need to be able to say about a solid. They have a fixed shape and they have a fixed volume as well. The other thing you need to mention about a solid is they have limited particle movement. So unlike liquids and gases that can flow, the particles in a solid have minimal movement. They do vibrate, so you might see pictures where we have these little lines coming off them to show that the solid is vibrating. but they don't move. They don't flow from one place to another. They vibrate. And as you warm them up, they can vibrate a little bit more. And as you cool them down, they'll vibrate less because of the amount of energy held within the particle. But they do stay and they have limited particle movement. So some examples, some everyday examples you might have heard of. Obviously, we've already talked about ice, which is frozen water, wood, metals. I talked about coins, which are made of metals already. But being a solid, the property of a solid makes it useful. So things that we want them to not change their shape and to keep a fixed volume, we can use them. So for example, in construction or electronics, you don't want your laptop to suddenly flow away. You don't want your brick wall to suddenly fall down. So in that respect, using a solid is beneficial. It's the right state of matter, the right object to pick for the job. The next one that we're going to talk about is liquids. And again, liquids are another fundamental state of matter in GCSE chemistry. And again, they've got some unique properties that we need to be able to describe. In terms of particle movement then, liquid particles have more freedom to move compared to solids. They can move past each other, but they do not escape the liquid. They can flow, and flow is a really good word to use when you're describing a liquid. So all the particles are still touching each other, they can move past each other, but they can't just float off and disconnect. All the particles stay within the liquid itself. The other key characteristics that you need to mention is that they have a fixed volume. Okay, liquids have a fixed volume, meaning that they maintain their quantity, but they can change shape to fit into the container that they are in. So if you have water in a jug and you pour it into a cup, it now takes the shape of the cup, no longer the jug. Okay, but they do have a fixed volume. In terms of particle arrangement, the particles are relatively close together, but they're not as tightly packed as in solids. And as we said, they are free to move past each other, which means that they can float. And that's a really good word to use when describing a liquid. Okay, but they still have that fixed volume. The thing that makes them different then, as we've just kind of hinted to solids, is that they have no fixed shape. Because they can flow, they do not have a fixed shape. They take on the shape of their container. Okay, as I said, you take the jug, you pour the water in, the water now takes the shape of the cup that you poured it into, not the jug. Some everyday examples: water we've already mentioned, milk, oil, a lot of the liquids you can think about in your kitchen would count. Understanding liquids is really, really important for understanding ideas like density and viscosity. Viscosity is thickness of a liquid, so if it's, you might know it's sort of runny or thick. Or density. Density is the number of particles in a set volume. So you might have two balls, same size, one sinks, one floats. Even though they're the same size, that's to do with the density. So understanding all of these properties, including how substances dissolve. So for example, a substance that dissolves in a liquid such as water might not dissolve in an alcohol or vice versa. So there's a lot of chemistry that we can learn, and a lot of physics we can learn, and a lot of important biological processes that rely on liquids. So they're very important for us to have an understanding of. Again, they vibrate just like a solid does, but they also have the ability to flow past each other as well. So now that we have covered liquids, we'll move on to gases. And the gases, again, a critical state of matter studied at GCSE chemistry, but they do have some distinct properties and characteristics that set them apart from solids and liquids. So particle movement. Gas particles are constantly moving. They have a constant rapid motion. They're moving around all the time. So if you take a blown up balloon, for example, it doesn't look like it's doing a lot, but if you could zoom in and see those particles inside the balloon, they'd be moving around all the time, and they'd be bumping into the sides of the balloon, and that's what actually helps the balloon keep its shape. All that impact of the particles, the gas particles inside, flying around, bouncing on the sides of the balloon. So they move freely, they can collide with each other and container walls, which is what I was saying with the balloon. And that collision actually creates what we know as gas pressure. They have no fixed shape and no fixed volume. Okay, so they do not have a fixed shape or fixed volume. They take on the shape and fill the entire volume of their container. So if you move them from a jug to a cup, you have the ability, if the jug is bigger than the cup, to compress the gas, so it will fit into a smaller space. But they will still take up the shape of the cup and the jug. Gases again can flow, just like a liquid can. They also have no fixed arrangement. So unlike solids, where the particles are tightly packed, gases have no fixed arrangement. They are widely spaced. You can change that spacing by changing the amount of pressure you apply to the gas. But generally, they are widely spaced out in whichever container they are within. The other thing that makes gases so interesting and so special to us, especially when we're learning about ideas in physics, is that they can be compressed, their compressibility. So gases are highly compressible, meaning their volume can be reduced by applying pressure. So that's what I said about you've got a big jug, you're in a small cup, you can fit the volume of the jug into the smaller volume of the cup, you just have to compress it in order to be able to do so. But also, you've got the idea of expansion. So gases will expand when they are heated and they contract when they are cooled. And we can use this idea a lot when we're creating systems, cooling systems, heating systems in our homes. We can use this idea. So common examples of the gases, well, we've already talked about water. In a gaseous form is steam, but you've got oxygen, nitrogen and carbon dioxide. And as we've already hinted at, understanding gases is essential for comprehending concepts such as gas laws, behaviour of gases in chemical reactions, and gases in our atmosphere as well. Again, gas particles are vibrating, but they're also moving incredibly quickly with a huge amount of energy, flying around whatever container they are held in, or if they're in the atmosphere, moving around in the atmosphere. So, just to give us a summary of everything in one place, this is everything that we've talked about so far, and a couple of extra ideas as well. So solids have a defined shape and volume. The particles in a solid are tightly packed and have a fixed arrangement. They also have strong intermolecular forces. That's forces between the actual particles within the solid. Intermolecular, so that's in between the molecules or particles. And they are not easily compressible. So they have this regular arrangement. They do vibrate, but it is around a fixed position and they are very, very close. With our liquids, they have a definite volume, but they take up the shape of their container, whatever container shape they are in. The particles in a liquid are close together, but not as tightly packed as within a solid, and they have moderate intermolecular forces. So those forces between the particles are not as strong as within a solid. Liquids are not easily compressible. They are randomly arranged, so they don't have that fixed arrangement like you see in the solids. They can move around each other. They're closely packed and able to slide over each other, but you don't get particles drifting off and separating from the liquid. And then finally, with our gases, they have neither a definite shape nor a definite volume. The particles in a gas are widely spaced and can move freely and move randomly in different directions. They have weak intermolecular forces and they are highly compressible. So as I said, their structure is randomly arranged. They move quickly in all directions, which gives us gas pressure. And the particles are not close at all. They are very, very far apart. So before we move on to the next bit, I've got some tasks here for you to complete. We've got 2 quizzes to start you off in order to check that you've understood everything so far. You can take the quizzes and then go back through parts of the video just to double check your knowledge. Then once you've done that, I want you to create a summary mind map or a Venn diagram of the similarities and differences between solids. If you're unsure about a Venn diagram, the best way to do it is you need to draw 3 circles, and these 3 circles are overlapping. It's a little bit tricky to draw out, but you can go online and you can find proformas if you put Venn diagram proforma. And then one of these is going to be for liquids, or one of these is going to be for solids, and then one of these is going to be for gases. And then you can see you've got these overlaps as well. So if anything is just for liquids, you write it in here, any facts just for solids up here, and any facts just for gases down here. Where the liquids and the gas box overlap, so here you put any facts that relate to both. Same here, anything that liquids and solids have in common in this gap, anything solids and gases have in common in this gap. And then you'll see you've got this tiny overlap in the middle for all 3. That is where you would put a comment that relates to all of them. So it might be solids and gases are all made of particles, or something like that. So that's how you draw a Venn diagram, but you're going to put in some of the facts that will then help you to classify the similarities and differences between solids, liquids, or gases. If you don't want to do the Venn diagram, you can just do it as a mind map. Once you've done that, there is an exam question for you to have a go at as well. You can complete that and see how you get on. Another useful thing for you to do is to head over back to your starter task, have a read through of your starter where you wrote about water and steam and the similarities and differences with that with ice, and see how far your knowledge has come in such a short time, and think about what sentences you can now add that you did not write originally.